Hello, everyone. Welcome to Lemon Code 21. In this video, we will talk about Golang unit test. Unit testing in Golang, is a fundamental practice that ensures code reliability and correctness. By writing unit tests, developers can validate individual functions or components, ensuring they work as expected. This is the agenda that we will discuss in this video. Introduction to software testing. Software testing is one of the scientific disciplines in software engineering. The main goal of software testing is to ensure the quality of our code and applications is good. The knowledge of software testing itself is very broad. In this material, we will only focus on unit testing. Unit tests will focus on testing the smallest part of program code, usually testing a method. Unit tests are usually made small and fast. Therefore, sometimes there is more unit test code than the original program code, because all test scenarios will be tried in the unit test. Unit tests can be used as a way to improve the quality of our program code. Introduction to testing packages. In other programming languages, usually to implement unit tests, we need a special library or framework for unit tests. In contrast to Golang, in Golang, a special package called testing has been provided for unit tests. Apart from that, to run unit tests, Golang also provides commands. This makes implementing unit testing in Golang very easy compared to other programming languages. You can see it in Golang testing package. Testing.t. Golang provides a struct called testing.t. This struct is used for unit tests in Golang. Testing.m. We will discuss this material later in the main chapter. Testing.m is a struct provided by Golang to manage the testing lifecycle. Testing.b. Testing.b is a struct provided by Golang for benchmarking. In Golang, benchmarking, measuring the speed of program code, is also provided, so we don't need to use additional libraries or frameworks. Create unit tests. Golang has rules for creating special files for unit tests. To create a unit test file, we must use the underlined test suffix. So, for example, we create the hello-world.go file, meaning that to create the unit test, we have to create the hello-world_test.go file. Function unit test rules. Apart from file name rules, Golang also has settings for unit test function name. Function names for unit tests must begin with the name test. For example, if we want to test the hello world function, we will create a unit test function with the name test hello world. There is no rule that the last name of the unit test function must be the same as the name of the function to be tested. The important thing is that it must start with the word test. Next, it must have a parameter, testing.t, and not return a return value. Start creating a Go project. We begin by running the command go mode init project name to initialize the project. In this file, we will write a simple function called hello world that takes a string input and returns a string output. The function will greet the input name by returning a message like hello name. Next, create a new file to test the hello world function. Make sure to name the file with the suffix underline test. Go, as this is the convention in Go for test files. We will declare a function called test_hello_world that accepts a parameter t of type testing.t. The t parameter is used to handle and report the results of the test. Inside the test function, we call one hello world atom, where one is the package or object containing the hello world function. The function is expected to take one string parameter, in this case atom. The result of the function call is stored in a variable result. Then, the result is compared with the expected string hello atom. If the result does not match, the test triggers a panic function indicating something went wrong, and it displays the message result wrong. If the result matches hello atom, the test will pass without any issues. If not, the test will fail and an error message will be displayed. Running unit tests. To run unit tests, we can use the command go test. If we want to see in more detail what function tests have been run, we can use the command go test v. And if we want to choose which unit test function we want to run, we can use the command go test v run test function name. Unit test coverage all. If we want to run all unit tests from the top module folder, we can use the command go test./. Navigate to the one folder and run the test using the go test command. You should see a successful result. If you want more detailed output, you can run the command go test v, which will provide a more detailed breakdown of the test results. Now, let's create a second test function called test_hello_world_James. This time, we deliberately test for a failure scenario. After writing the test, run it, and you will see that the test fails. The program will exit immediately and display an error message. If you want to run a specific test function, you can use the go test vrun function name command to execute only that particular test. To run all tests in the project, you can use the command go test v. This command runs all test files and test functions within the project directory. Failed the test. Failing unit tests using panic is not a good thing. Golang itself has provided a way to fail unit tests using testing.t. There are functions fail, failno, error, and fatal. There are two functions to fail unit tests, namely fail and failno, so what's the difference? Fail will fail the unit test, but continue executing the unit test. However, when it is finished, the unit test is deemed to have failed. Failno will fail the unit test at this time without continuing to execute the unit test. Besides fail and failno, there are also error. In fatal, the error function is more like logging, printing errors, but after logging the error, it will automatically call the fail function, resulting in the unit test being considered failed. However, because it only calls fail, it means the unit test execution will continue to run until it finishes. Fatal is similar to error, only after logging the error. It calls failno, causing the unit test to stop executing. First, we create a basic hello world function. Then, we will replace a part of the test with the failno function. If the output does not match the expected result, the t.failno method is used to stop execution and indicate that the test has failed. Let's try it now. The result will be different from using panic. When using panic, the program exits immediately with an error. But when using failno, it just notifies that the test has failed. Next, let's try using the fatal function. This function tests the input James by calling to.heyworld. James, however, the comparison is made with the string hello Adam, which is also incorrect. Let's run the test now. The result is that if the test fails, the execution not only stops, but an error message is displayed. Result wrong. Must be hello James. The t.fatal function halts execution and logs the failure. Finally, we will test using the error function. This function tests the input Darren, but again compares the result with hello Davis, which is incorrect. Let's run the test now. The result is that if the test fails, an error message will be recorded, result wrong. Must be hello Darren, but unlike t.fatal or t.failno, the execution does not stop immediately. This allows other tests within the function to continue running. Assertion. Carrying out checks in unit tests manually using if-else is very annoying, especially if there is a lot of result data that needs to be checked. Therefore, it is highly recommended to use assertion to carry out checks. Unfortunately, Golang does not provide a package for assertions, so we need to add a library to perform this assertion. Testify. One of the most popular assertion libraries in Golang is Testify. We can use this library to perform assertions on result data in unit tests. We can add it in our Go module. Assert vs require. Testify provides two packages for assertion, namely assert and require. When we use assert, if the check fails, then assert will call fail, meaning that unit test execution will continue. Meanwhile, if we use require, if the check fails, then require will call fail no, meaning that unit test execution will not continue. Alright, now let's perform testing using the Testify library. As we have seen, Testify offers many packages that can be used for testing. Most Go tests typically use the Testify package. Okay, let's just import the library from Testify. This function is a unit test used to test the Hello World function from the one package with the input James. After calling Hello World, James, the result will be stored in a variable called result. This function uses the assert equal method to compare the expected result. You don't need to use an if condition to check the result anymore. Simply call the assert function from the Testify package to handle the comparison. Now, let's try using the require function, and the result will provide a more detailed explanation of the test. Well, let's try testing now. If we look at the results, the use of the require function provides more detailed information in conducting tests, such as the expected, actual, test message attributes, and others. The require function is usually used much more often by Golang users in conducting testing. Skip test. Sometimes, under certain circumstances, we want to cancel unit test execution. In Golang, we can also cancel unit test execution if we want. To cancel a unit test, we can use the skip function. Next, we create a test skip function, which is used to test the Hello World function. We use the constant runtime, GOOS, which is set to Windows. If the value is Windows, the T skip cannot run on Windows. Function is called to skip the test with the reason cannot run on Windows. This prevents the test from being run in unsupported environments. Next, we add the require function to observe the test results. We try to test the wrong one, then the result is executed. It turns out there is a typo, it should be Windows. Let's see the result. The result of the test that is done is skip because the system is running on Windows. Before and after tests. Usually in unit tests, sometimes we want to do something before and after a unit test is executed. If the code we do before and after is always the same between unit test functions, then manually creating the unit test function is tedious and results in too much duplicate code. Luckily in Golang there is a feature called testing.m. This feature is called main, which is used to manage the execution of unit tests, but we can also use this to do before and after in unit tests. Testing.m. To manage unit test execution, we simply create a function called testMain with the parameter testing.m. If there is a testMain function, then Golang will automatically execute this function every time it runs a unit test on a package. With this, we can set the before and after unit tests according to what we want. Remember, the testMain function is executed only once per Golang package, not per each unit test function. We will try the before and after test. Previously, we copied a function from before. To run the before and after test, we need to create a function with a testing parameter of type .m. Calling a method like run, which will run all the tests that have been defined. If we try the test, the results contain the before and after process. Here you can see that before m.run, all test processes are run, and after m.run, you can execute the code afterwards. Subtest. Golang supports the function unit test creation feature within the unit test function. This feature is a little strange and is rarely found in unit tests in other programming languages. To create a subtest, we can use the run function. Running only subtests. We already know that if we want to run a unit test function, we can use the command go test run testname function. If we want to run only one of the subtests, we can use the command go test run test function name / subtest name. Or for all tests, all subtests and all functions, we can use the command go test run / subtest name. In this particular subtest, labeled James, the purpose is to verify that the Hello World function behaves correctly when given the name James as input. The subtest begins with t.run, which creates a separate test case within the broader test function. By using subtests, the code becomes more organized, and individual test results are easier to track. Within this subtest, the function Hello World from the one package is called with James passed as the argument. The expected behavior is that Hello World James will return a string greeting Hello James. The result of this function call is stored in a variable named result. Next, the require equal function is employed to compare the result with the expected output, Hello James. This function checks whether the two values match. If they don't, the test will fail and an error message stating result must be Hello James will be displayed. Next, we just copy the function. We create the second function Darren and the third function Ronaldo. Now we have three functions that will be tested in one subtest. Let's just try it. The results can be seen here that in the test there are child tests again, meaning we can do many tests in one test function by using subtests. Table test. Previously, we learned about subtests. If you pay attention, actually with subtests, we can create tests dynamically. And this subtest feature is usually used by Golang programmers to create tests with the table test concept. Table test is where we provide data in the form of slices containing parameters and expected results from the unit test. Then we iterate over the slice using subtests. While on this occasion, we create a Hello World test table. First, we create a list object struct, in which there are attributes name, request, expected with string data type. Then enter data or create example data. The first James request is James and expected is Hello James. We create the second Ronaldo and Messi. After that, we create a loop from the list object struct that we just created. In each iteration of the for loop, t.run is used to run each test case with the appropriate name, then call the hello world function with the request input from the test case. The require.equal function from the testify/require package is used to ensure that the results given by hello world match the expected values. If the results do not match, the test will fail and display an error, but if the results match, the test will pass. As you can see, the results are almost similar to the subtest, but the table test structure can make testing easier. Mock. Mock is an object that we have programmed with certain expectations so that when it is called, it will produce the data that we have programmed at the beginning. Mock is one of the techniques in unit testing, where we can create a mock object from an object that is indeed difficult to test. For example, we want to create a unit test, but it turns out that there is a program code that must call an API call to a third-party service. This is very difficult to test, because our unit testing must always call the third-party service, and the response is not necessarily what we want. In cases like this, it is very suitable to use a mock object. Testify mock. To create mock objects, there are no built-in Golang features, but we can use the assertion library that we previously used for assertions. Testify supports creating mock objects, so it is suitable for us to use when we want to create mock objects. However, please note, if our program code design is bad, it will be difficult to do mocking, so make sure we design our program code well. Let's make an example case. Next, we will create mock tests, which are commonly used for testing APIs. We will create several test scenarios for retrieving book data by ID. First, we will create a model or entity called book. The book model or entity will have 3 attributes, ID, title, and author, all of which will be of string data type. Next, we will create a book repository as an interface, which will contain the findById function that returns a book model. We will then create another file to implement the previous interface and add the findById function. The findById function will be declared as a method belonging to mockBook repository. Its purpose is to retrieve the details of a book based on its ID. However, since this is a mock, the implementation will not perform an actual database search. Instead, it uses the m.called_id method from mock. Mock to record the function call and determine the mock response according to the test scenario. m.called_id is used to record that this function has been called with a specific argument. args.get0 returns the first value, in this case, the book object, that was set by the test when the mock call was made. If the return value is not nil, it is converted to the entity. Book type representing the actual book object. args.error1 returns the error set by the test. This is used either when a book is found with a nil error or if the book is not found with an appropriate error. Time to create tests. Test findById success. This test verifies the scenario where a book is found based on the given ID. First, an instance of the mock repository, mockBook repository, is created, which will be used in the test. Then, a mockBook object, mockBook, is created with details like ID, title, and author. This mock object will be returned when the findById function is called. Next, we define that when the findById function is called with ID1, the mock will return the mockBook object and nil, indicating no error. This simulates the scenario where the book is successfully found. In this part, the function being tested is called findById1. The result of this function is stored in the book variable for the book object and error for the error. Now, create the assert nowhere function to ensure that no error occurred and that the book object is not nil. Create the assert equal function to verify that the book object was found, confirming that the title and author match the expected values. Finally, use assert expectations to ensure that the findBy function was called with the correct parameters during the test. Test findBy not found. This test verifies the scenario where a book is not found based on the given ID. The steps remain the same, but no data is declared for the book, so the value will be empty. Once we run the tests, the results will show how the findBy function responds in two different situations. First, when a book is found, successful scenario. Second, when a book is not found, failure scenario. By using mocking, these tests can examine the function's behavior without relying on an actual database, ensuring that tests are faster and more controlled. Benchmark. Apart from unit tests, the Golang testing package also supports benchmarking. Benchmarks are a mechanism for calculating the performance speed of our application code. Benchmarking in Golang is done by automatically iterating the code that we call many times until a certain time. We don't need to determine the number of iterations and their duration because that is already set by the default testing. B from the testing package. Testing.b. Testing.b is the struct used to benchmark. Testing.b is similar to testing. T. There are functions fail, failNow, error, fatal, and others. What is different is that there are several additional attributes and functions used to benchmark. One of them is the n attribute. This is used to carry out the total iterations of a benchmark. How benchmarks work. The way benchmarks work in Golang is very simple. How about we only need to repeat a number of n attributes? Later, Golang will automatically execute a specified number of iterations automatically, then detect how long the process has been running, and conclude its benchmark performance in time. Create benchmark. Similar to unit tests, even for benchmarks, in Golang the function name has been determined. It must begin with the word benchmark. For example, benchmark hello world, benchmark suck. Additionally, it must have a parameter btesting.b, and it cannot return a return value. For benchmark file names, the same as unit tests, end with test. For example, hello world test. Go. In this code, the function benchmark hello world is used to measure the performance of the hello world function when called with the input James. This is part of Go's benchmarking framework, which helps developers assess how efficiently a function runs, particularly under repetitive or heavy use. The function begins with a loop that runs for b, and iterations where b en is automatically set by Go's benchmarking tool to determine how many times the code inside the loop should be executed. Each iteration calls one hello world James, simulating repeated calls to this function. Running benchmark. To run all the benchmarks in the module, we can use the same command as test, but add the bench parameter, go test vbench equals. If we just want to run benchmarks without unit tests, we can use the command, go test vrun equals not mathunitis bench equals. The code above, apart from running benchmarks, will also run unit tests. If we only want to run certain benchmarks, we can use the command, go test vrun equals not mathunitis bench equals benchmark test. If we run the benchmark on the root module and want all modules to run, we can use the command, go test vbench equals //. We will try to run the test by simply running the command go test v-benchmark with the same function name. By running the benchmark multiple times, Go collects performance data, such as the average time per operation and the number of iterations. This benchmarking process helps developers understand how well Hello World scales with repeated usage. It can reveal potential bottlenecks or inefficiencies in the function's implementation. Benchmark results can also be compared over time, enabling the team to optimize the function for better performance if needed. By using this approach, the developer gains insight into how the function behaves in scenarios with a high volume of calls. Sub-benchmark. Just like testing.tt in testing.b, we can also create sub-benchmarks using the run function. When we run the benchmark function, all sub-benchmarks will run. However, if we want to run just one of the sub-benchmarks, we can use the command go test vbench equals benchmark name slash subname. Now we will try the subtest benchmark. The method is almost the same as the previous subtest. Now we just copy the existing run function. We copy it twice. Next, we try it. The results can be seen. All the benchmarks from the subtest are displayed. Table benchmark. Just like in unit tests, Golang programmers are used to creating benchmark tables too. This is used so that we can easily carry out performance tests with different data combinations without having to create many benchmark functions. As usual, to create a test table is the same as the previous test table. The difference is that the parameters use testing.b. We first create a list of object structs with name and request attributes. Then create a looping benchmark. After that, we try to run it. The results are almost the same as the previous subtest. Finally, the tutorial process on the Golang unit test has ended. Next, we will discuss Go Routine, Go Database, and Go Web. See you!